Today we're going to look at some free response questions based off of content from Unit 8. So this particular question came from a previous AB exam, and it's going to have a lot of familiar aspects to what you've seen before, but now we're going to look at it from a more complicated integral perspective from stuff we've done in Unit 8. So here's the scenario. You can see at the top here we've got a table in terms of hours and E of t, which is hundreds of entries. And these are entries at a zoo. A zoo sponsored a one-day contest to name a new baby elephant. Zoo visitors deposited entries into a special box between noon, which is when t equals 0, and 8 p.m., where t equals 8. The number of entries in the box t hours after noon is modeled by the differential function represented by the table, which is function e, from t to 8. Specific values at various times are shown in the table. Now, a couple things that we just want to make sure we understand is what does the table represent, and specifically it's the number of entries in the box after noon. So right here at 0, 0, this is noon, and then at 2, then this would be like 2 p.m., this would be 8 p.m., and so forth. So part A, using the data in the table to approximate the rate at which entries were being deposited at time is equal to 6. Show the computations that led to your answer. Now, as I look at this, 6 is right between 5 and 7. Right there is where 6 is going to be. But I don't have 6 on the table. So I'm going to need to estimate. And we want to know the rate. We want to approximate the rate in hundreds of entries that were being deposited at time equals 6. So for part A, we're looking at trying to figure out what E prime of 6 is going to be. What is the rate at 6 p.m.? And the only data that I have is the data directly around it. So we're going to estimate this, and I should use the approximation symbol here. And the only data that we have is E of 7 minus E of 5 all over 7 minus 5. We're going to find the slope between those 2 points, and that's going to give me my rate of change. Now, in this case right here, E of 7, we can see is going to be 21. E of 5 is 13 over 7 minus 5. So we see that we are going to have approximately 400 entries an hour. So it's about 400 entries an hour. Looking at B then, we want to use a trapezoidal sum with 4 sub-intervals. Now notice right here it's trapezoidal and we've got 4 sub-intervals. If on the AP exam I use my left Riemann sum or right Riemann sum and I did the wrong sub-intervals, you will not get credit for the answer. So we do want to do a trapezoidal sum. And just as I think about trapezoids, we're going to be dealing with something like this, which means I'd have my 2 bases and I'd have my height. And you know the area of a trapezoid is going to be 1/2 b1 plus b2 times h, or some other variables that you might have used to represent that. So I'm going to head back to the top here, and my 4 areas I'm looking at are going to be from 0 to 2, 2 to 5, 5 to 7, and 7 to 8. So I'm going to create my 4 trapezoidal sums using that. So we want to approximate 1/8 from 0 to 8 of et dt using trapezoidal sums. So this is going to be approximately 1/8. And then I need to look at my first trapezoid. And it's going to be 1/2 And then I'm going to add my two bases, which in this case is going to be 0 and 4, and then multiply by the height, or the width in this case, of the trapezoid, which is the distance between the hours, which is 2. So there's my first trapezoid. Then my second trapezoid is going to have a left-hand base of 4, a right-hand base of 13, and then that width or height is going to be 3. Then for my third trapezoid, 1/2 times 13 plus 21. And the height or width of this one is going to be 2. And then finally we've got 1/2. And then my two sides are going to be 21 and 23. And then the height of it, or if you want to look at the width once again, is going to be 1. So there's going to be my 4 subunits using a trapezoidal sum. I'm just going to plug that into my calculator, and this ends up being approximately 10.688 hundred entries an hour. So you get about that. Now, what is this in terms of the context of the problem? What we are saying is that the average number of entries in the box between noon and 8 p.m. was about 1,068. And that lines up with our average value function. Remember we talked about 1 over b minus a in front of the integral? That's what that 1/8 represents, because we're looking at an 8-hour interval. If you need to review that, head back and look at AP Objective 8.1.